Subscribe now and press the bell icon. Never miss an update.
Welcome to my mathematics class. Let's see today's topic. Today's topic is Exponential Series Part 2. I've taken this topic from grade 12 book. Show that three questions I have taken. Show that this is equal to this, and this is equal to this, and this is equal to this. All three questions are very important from the examination point of view. If you are in a grade 11, then this topic, this video is very important to you. All right, so let's start. The first question: how to prove? So first question. Before taking the left hand side, I would like to tell you this something. We know E is equal to expansion of E, 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus 1 upon 4 factorial and dot and your E raised to power minus 1. Let's say this is the first. E raised to power minus 1 is 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial and plus 1 upon 4 factorial and minus dot. This is a second. Okay? Now using, okay, with the help of this, we will try to prove this question. Now adding 1 and 2, adding 1 and 2, I'm going to tell each and every step in very easy way so that you will not have any kind of problem. Adding first and second, we get, what do we get? E plus E raised to power minus 1 is equal to this plus this 2 and okay, get cancelled, and this plus this 2 upon 2 factorial get cancelled, and 2 upon 4 factorial plus and so on, right? Or E plus E raised to power minus 1 to common, 1 plus 1 upon 2 factorial plus 1 upon 4 factorial and dot. Or you will get, okay, 1 plus 1 upon 2 factorial plus 1 upon 4 factorial plus and 1 upon 6 factorial plus dot is equal to, and here 1 upon 8 factorial and so on. You will get E plus E raised to power minus 1 upon 2. Okay, so I don't think you have any problem. So this, let me say this is a 3. Now firstly, okay, be added. Now I'm going to subtract, okay. Subtracting the second from first. Subtracting second from first, we get E minus E raised to power minus 1. See, if you subtract, okay, here sign negative, cancel, here plus. So 2 upon 1 factorial plus minus and cancel plus 2 upon 3 factorial and minus cancel, and you will get here 2 upon 5 factorial and so on, right? Here I have not written 5, so it will count, right? And or E minus E raised to power minus 1 to common, 1 upon 1 factorial plus 1 upon 3 factorial plus 1 upon 5 factorial plus dot, or therefore you will get, okay, 1 upon 1 factorial plus 1 upon 3 factorial, 1 upon 5 and so on is equal to E minus E raised to power minus 1 upon 2. So this is, okay, let's say this is the 4, okay, right? Now we will use, okay, these two results to prove is here factorial, or these two results, okay, or we will try to prove the first question, okay, and these two results. I'm going to use here these two results to prove the your first question, okay. Now we can take, okay, left hand side. Now I'm going to take left hand side. So on the left hand side you have 1 over 2 factorial plus 1 over 4 factorial plus 1 over 6 factorial plus dot and here 1 upon 1 factorial, 1 upon 3 factorial plus 1 upon 5 factorial plus dot dot. Okay, this is the left hand side. Now listen to me. We can get in this result. Okay, so here 1 upon 2 factorial, 1 upon 4 factorial plus 1 upon 6 factorial. Only we are missing here 1, right? So if we write here 1, then our this result will be complete, and as a consequence we can write down instead of that a plus e raised to power minus 1 over 2, right? So okay, in denominator, if you see the denominator and see this result, you will find exactly we have a denominator in this form. Instead of this expansion, we can write down e minus e raised to power minus 1 whole upon 2. Okay, so let me here 1 plus 1 upon 2 factorial plus 1 upon 4 factorial, 1 upon 6 factorial plus dot dot, and here minus 1, because I have added here 1 in expansion, so that's why I need to write down minus 1. Okay, in denominator we don't want anything. 1 upon 3 factorial and plus 1 upon 5 factorial and plus so on, right? Dot dot. Okay, now I'm going to write down here. So it's in. See, I'm going to write down here is equal to, you are getting instead of this result, okay, e plus e raised to power minus 1 over 2 minus 1, okay, upon instead of this we can write down this e minus e raised to power minus 1 upon 2, okay. Now we have used these two results. Now I'm going to erase from here. All right. Let's simplify. Is equal to e plus e raised to power minus 1 by 2, and here also e minus e raised to power minus 2. No, sorry, e plus e raised to power minus 1. 2 will be cancelled out, right? You know. Now one more thing we can do here. Negative, so we can write down minus 2 e minus 1 upon e. So again here LCM, and then simplify e square plus 1 minus 2e over here e square minus 1, because here also in upon e, here also we'll get in upon e, so e will be cancelled out, right? So after this I'm writing here is equal to, so if you see this one is e square minus 2e plus 1 over e square minus 1 square, you can write down. Now this is in the form of a square minus 2ab plus b square. We can write down e minus 1 whole square, and here e minus 1 e plus 1 is equal to e minus 1 and e minus 1 upon e minus 1 and e plus 1, right? Now it can cancel, they can be cancelled, and we have finally e minus 1 upon e plus, which is your right hand side. This way we can prove. Alright, so I also think you have a problem. Now fully you understood the first question. So first question done. Important, very very important, right? Now I'm going to tell you the second question now. Second question, how to prove question based on exponential series. These are important questions I have taken. So before this video also I have made one video on exponential series first. In that also I have taken very important questions, right? Remaining questions I'm going to teach today. So see the next question. Your question number second. Okay, second question. Your left hand side solution. I'm taking here left hand side. Left hand side is your sigma n is equal to 1 or summation infinity n square over n plus 1 factorial. Right? Now how to do it? Listen to me, okay? We have to keep only one concept, how to remove n square from numerator. Okay, so let's try to remove. And then we'll get an easy form. Sigma n is equal to 1 to infinity. It's very easy. see here what I'll do. Okay, you can see n here n plus 1, right? Here n square, you can do n minus 1 because n square minus 1, we can write n minus 1 n plus 1. So n square minus 1, and because minus 1 I have subtracted, okay, this okay, or minus 1 from this, so I need to add, okay, n plus 1 factorial. I think you understood. Now you can write down separately n is equal to 1 to infinity n square minus 1 upon n plus 1 factorial and plus 1 upon n plus 1 factorial. Okay, so here you will use square bracket. So alright, here no n in numerator. So okay, here we can expand this, no problem. Now let's simplify this one. And here sigma n is equal to 1 to infinity. So I'm not skipping any step. I'm going to tell you in detail. N minus 1, n plus 1, and here you may write down n plus 1 and n factorial, right? Okay? N factorial stepwise, because n plus 1 factorial, n plus 1 n factorial, expand it up to n factorial over n plus 1 factorial is equal to sigma n is equal to 1 to infinity, cancelled, and here we got, okay, n minus 1, they can be cancelled. Here n factorial, again n factorial, we can expand, okay, n, okay, so write down only n factorial, okay, up to only n factorial write down, okay, then we can, I'll tell you the next step, n plus 1 factorial here. Okay, now we can write down this upon this upon, separately we can write down, okay, like this way we can write down, it will be easy to simplify. Again he forgot, okay, again in this term in numerator we have a one constant, not n, so n plus 1 factorial. Now only you have to do work here, how to remove, so it's easy now, and it's going to be removed, is equal to sigma n is equal to n to infinity, here n minus 1 factorial minus 1 over n factorial plus here 1 upon n plus 1 factorial. Okay, so I don't so think you have a problem here, cancel. So finally sigma n is equal to 1 to infinity, here you are getting, okay, 1 upon n minus 1 factorial minus 1 upon n factorial plus 1 upon n plus 1 factorial. Okay, now, okay, now we'll write down, okay, right, separately. So after this I'm going to tell here sigma n is equal to 1 to infinity 1 over n minus 1 factorial minus sigma n is equal to 1 to infinity 1 over n factorial plus sigma n is equal to 1 to infinity 1 over n plus 1 factorial. Okay, so no problem. Now we will write down in expanded form, okay, here 1 upon 0 factorial. When you will use, okay, here 1 to infinity you can use here 1 upon 0 factorial. 1 upon 0 factorial is 1 plus here 1 upon 1 upon 1 factorial, 1 upon 2 factorial. You understood, okay? N is equal to 1, 0. 0 factorial is 1, okay? 0 factorial is equal to 1. So that's why I've written directly 1. When you will use, okay, 2 minus 1, 1 factorial, 1 upon 2 factorial, 1 upon 3 factorial, and so on, right? And the minus, so let's write down the expanded form of this one. 1 over 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial, and so on, okay? And plus, and the expanded form of this one, you can write 1 upon 2 factorial, because when you will use, okay, 1 plus 1 2 factorial plus 1 upon 3 factorial, 1 upon 4 factorial, and dot dot. Okay, as you wish, how much you want to write down here, right? So at least, okay, 3-4 terms you need to write down. So now I'm going to erase, okay, few lines. Now I'm going to write down here. So this line is here. Is equal to, this is in formula. e factorial, sorry, e is equal to 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus dot dot and so on, right? Here, uh, okay, so this is e we can write down, but this is not e, okay. Here, okay, 1 we need, okay, 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus dot dot. We have added here 1, we need to subtract, okay, right? Like this we can write down. And here also we need, okay, two things, okay. One is 1 upon 1 factorial. So we are going to add here 2 plus 1 upon 2 factorial and plus 1 upon 3 factorial plus dot dot and 1 plus 1 upon 1 factorial. So minus 2 you can write down. Okay, so no problem, is equal to e minus, okay, now this is e minus 1 and plus this one is a e minus 2, okay. So e is equal to e minus e, let's open the bracket, 1 plus e minus 2 and okay, going to be cancelled, and here e minus 2 plus 1 is equal to minus 1 is equal to right hand side. Like this way we can prove, hence the proof. Okay, so finally we write down hence the proof. Like this way we can prove, right? So easy, not so difficult. All right, each and every step of this proof I have, okay, told, right? I have explained, okay. So if you have a still problem, you can tell me, no problem. Now I'm going to tell you the last question, right, of this video. Last question. Your last question, let's see. Two question done, and now question number 3. Solution here. So okay, by taking left hand side directly we can't go, it will be a little bit difficult, okay. Let's try it by using t and tom, right? Means let t and be the, okay, be the nth term of the series. So series is this one here, 1 plus 1 plus 2 upon 2 factorial plus 1 plus 2 plus 2 square over 3 factorial plus dot dot, okay. Then let's see your Tn. What will be your Tn? So let's analyze. First term is 1, second term 1 plus 2, and in third term 1 plus 2 square. Here power is, okay, here if okay third term then power is 2, if okay fourth term then power is 3, 1 less. So in nth term power will be in minus 1. We shall write 1 plus 2 square plus and 2 cube plus dot dot, and at the nth term we will have 2 raised to power minus 1, surely, right? Here 2 power is 1, 3 power is, okay, right? Over here, in here, okay, nothing written in denominator. This means 1 factorial you can say, and 2 factorial third term, okay, in second term 2 factorial, in third term, okay, 3 factorial. So in nth term, okay, definitely n factorial. So now matching, okay, say 2 power is 1, 3 factorial, here 3, so power is 2, n minus 1, 1 less, okay, right? So this way, anyway, okay, you can make sequence yourself, right? Okay, this is a Tn, nth term of this series, okay. We have to find out the sum, you know, right? If you see this one, this is sum of first and right terms of GP. Here, okay, GP, because ratio is same, okay. And GP, what is the formula of Sn is equal to a r raised to power n minus 1 over r minus 1. We need to use this formula. Don't forget this formula, okay. Here n terms, okay, there are n terms, okay. So 1 first term is 1, a is your first term, r is common ratio, is first term. If a problem first term, r is your common ratio, all right. R is a common ratio, A R. Common ratio means 2 upon 1 is equal to 2. Sorry, 2 square upon 2 is equal to 2. Or a common term, how to find out? Second term upon first term, third term upon second term, like this we can find out, right? Okay, so yes, 2, common ratio is 2 raised to power n, because n terms are there, over and r minus 1, 2 minus 1 upon n factorial. Okay, so now I think, okay, which one formula we have applied here? This one formula. I'm going to erase, I need space here. Yeah, 2 minus 1, 1 simply. Here you will get, okay, 2 raised to power n minus 1 over n factorial. You can write down, okay, here 2 raised to power n over n factorial minus 1 upon n factorial. This is a Tn. Let S be the required sum. Then you can write down here, let S be the required sum, then S is equal to sigma, okay, n is equal to 1 to infinity, sigma n is equal to 1 to infinity of Tn, or sigma or summation 1 to infinity, here 2 raised to power n over n factorial minus 1 upon n factorial. Now let's write down, okay, separately we can write down sigma n is equal to 1 to infinity 2 raised to power n over n factorial minus sigma n is equal to 1 to infinity 1 upon 1 factorial is equal to, so see here, let's expand this one. 2 raised to 1, 2 upon 1 factorial plus 2 square upon 2 factorial and plus and 2 cube upon 3 factorial and plus dot dot and minus here 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus dot dot. Okay, no problem. So this is also not in complete in formula. This is also not in complete formula. We need here 1. It should be started from the 1 plus. Here also we need 1, right? So let's, okay, add, okay. So 1 plus 2 upon 1 factorial and plus 2 square upon 2 factorial plus 2 cube upon 3 factorial plus dot 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 and minus here also 1 minus 1 over 1 factorial, plus 1 over 2 factorial, 1 over 3 factorial plus 2. Now, okay, this is in formula, this is also in formula. So we have added 1 here, added 1 here. When you will open the bracket, it becomes minus 1. So 1 minus 1, 0. So they will cancel. So, okay, here whatever we have added here and here, they are already in balanced form, right? They are not going to disturb the equality, right? Okay, now so if you are thinking this is the formula of, so this is the formula of E square. I'll tell you, okay, which one formula here. Okay, this is the formula of E. Okay, E. So, okay, this is equal. All right, we need only right hand. This is your right hand. So, which one formula we have used? This one. E raised to power x is your 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial. All right, that's already in formula. Okay, E raised to power x. I have used, okay, here e raised to power x formula. Instead of x, okay, here you have, okay, 2 square, just like here x square x cube, here 2 square 2 cube, right? So we can write down, okay, e square minus e. This is the formula e square and this is the formula for e. Okay, so now you understood, okay, which one formula we have applied here. All right, so this way we got, okay, right hand side. Hence proved, you can write down, or hence the proof. So very important, these are questions, okay. If you are in a grade 12, if you are in a grade 11 also, you can go through this question. These are important for all, right? So very important question from the examination point of view. Thank you very much for watching. Bye bye.